Hi, welcome to the eighth and final unit of bioprocess technology. This unit deals about enzyme technology, how enzyme can be used in bioprocess technology. So basically, enzymes in bioprocess technology are used in immobilized form. So we are going to discuss about enzyme immobilization. Before that, there are several advantages for enzyme bioprocess or enzyme process over the chemical process. Traditionally, most of the reactions are catalyzed by chemical catalysts. But due to the advancement of bioprocess technology and especially to the recombinant DNA technology, we have the access to the enzymes for which can be used for the transformation processes. So there are in this case we can use enzyme as an alternative for other technologies like chemical process can be replaced by enzymatic process or the fermentation process in some cases can be replaced by enzymatic process. So these are the advantages. I am listing out the advantages of enzyme process over chemical process and the fermentation process. First one is the complex chemical conversions. The enzymes can do complex chemical conversions. When we are doing the same process using the chemical catalyst, it need multiple steps. But in case of enzymes, it can do the complex chemical conversions with high specificity. Secondly, mild environmental conditions are required. When compared to chemical process, enzymatic process need only mild conditions of temperature, pressure and presence of the other toxic chemicals is avoided in case of bioprocess like enzymatic process. High specificity in enzymatic process are so specific that even the chiral specificity can be achieved in enzyme process. High efficiency. The enzymes are sophisticated catalysts which can speed up the reaction in higher folds. So it is specific as well as efficient. Less undesired products. Enzymatic reactions are so specific that side products and undesired products are very minimal or absent. But in case of chemical process, if even if, especially if it is a multi-step process, most of the intermediates will be accumulated and they will be byproducts or side products. So which will add a huge amount to the downstream processing and purification of the real product. Increased plant capacity and yield. If we are using enzymes which is more efficient and more specific, so we can actually do it in very large scale and it can produce unique products. Some of the products like biological products which is very difficult to make with the chemical process or impossible to make with a chemical process can be easily synthesized using enzymes and it can do a variety of chemical transformation. So due to these reasons, actually enzymatic process is favored and it is has more advantages than the chemical process. But we are not using these enzymatic reactions that often. The reasons for the hindrance for the application of enzymes is due to the limited availability. Even if enzymes are very specific, very efficient, and a lot of good characteristics, the enzyme use is limited because of limited availability of the enzyme. In order to get the enzyme, we need to grow the microorganism, and after growing, we need to purify the enzyme. And this purified enzyme can be used for the chemical process, like transformation process. But in case of chemical catalyst, we just need to buy the catalyst and it will be there forever, or it can be used many times. But in case of enzymes, in order to get the enzyme, we need to culture the microorganism. We have to run a fermentation process to get the enzyme. Then only we can think about the enzymatic process. So the enzyme process is a two-step process. In first stage, we need to make the enzyme. In second stage, we are using the enzyme. So the availability is limited and the cost is high because of the production and the purification of the enzyme is an expensive business. Next important point is instability. If you are taking the chemical catalyst, most of the chemical catalysts are very stable. We can use it again and again, maybe 100 times or 200 times we can use the same catalyst. But enzymes are biological components, they are proteins. It will use to denature. If you are using it continuously, it will denature. It can denature due to many reasons. Even if we are using controlling almost all parameters, eventually it will denature. maybe 2 or 3 cycles, its activity will be reduced. But the chemical catalysts are more stable. It can be reused many times because they are more stable. And finally, the most important limitations of enzyme application is difficulty and expensive to recover it from the effluent. Once the reaction is over, when the enzyme is converting the reactants into products, we need to get our enzymes back. But it is difficult to isolate the enzyme back enzymes are proteins, so we need to run different procedures for the purification of the protein to separate our biocatalyst from the reactants and the products. So these are the main limitations which limits the wide use of enzymes in bioprocess and other chemical process industries. So what we can do to avoid these limitations is the enzyme immobilization. We are immobilizing the enzyme in some solid support so that it won't move, so that the previous limitations can be overcome. The definition of enzyme immobilization goes like this. Enzymes are physically confined or localized in certain defined region of space with retention of their catalytic activities and which can be used repeatedly and continuously. So enzyme immobilization is basically physical confinement or localization. Physically, enzymes are attached to a surface or a substrate. Okay, it is physically attached. It cannot go away. So if it is a solid support, enzymes are physically attached to it and it is localized. It cannot actually go away from it. So that is first point of enzyme immobilization. But while doing so, its catalytic activities are retained. So it is catalytically active, but it is localized in a space. Okay, and as it is localized and it is active, we can use it again and again, and it can be used for a continuous process. So instead of using enzyme as a solution, what we do here is that we are attaching it to a solid support. So enzymes are some way attached to the solid support. So if you have a solid support which is covered with the enzyme, you can actually use this enzyme for a reaction. Okay, you can dip this strip of enzyme to a solution of reactants to make it into products. Once the reaction is over, you can actually remove the solid support. So as the enzymes are physically attached to this solid support, when we are removing the solid support, the enzymes along with it will be also removed. So some way we are attaching the enzyme into a solid support while retaining the enzyme activity. So enzymes are active, but it is some way attached to a physical surface. So it will allow us to reuse of the enzyme. So one of the main limitation of enzyme catalytic reaction is that enzymes cannot be reused. The recovery is expensive. So once we attach it into a solid support, we can actually use it again and again. Just like the chemical catalyst, we can use it multiple times. So that limitation is over by the enzyme immobilization. And sometimes we can use the enzyme for 100 times, just more efficient than the chemical process. So the process will become more economical. So it can be used economically in bioprocess industry, wastewater treatment, medicine and biosensors. So this is what the enzyme immobilization is. We are attaching our enzyme into a solid support and it is localized. Its activities are it remain active and it can be reused repeatedly and continuously. So that's what the enzyme immobilization is. So most cases we are using insoluble matrices so that it retain the proper reactor geometry and economic reuse under the stabilized conditions. So the main objective is the reuse of the enzyme. So once we attach the enzyme to a solid support, we can actually use it again and again without losing its catalytic activity. So this enzyme mobilization was a revolution in enzyme technology. It's actually decouple enzyme location from the flow of liquid. If you have a, like let's say the enzyme is situated in a solid strip or something like that, you can actually dip the enzyme into the reactants. So the enzyme will convert reactants into products. Once the reaction is over, you can actually remove the strip so that you will remove all the enzyme. Your product will remain there. So the downstream processing is so easy when we are using immobilized enzyme. It can be used for the continuous process. Sometimes the engineers design some tubes which immobilize the enzyme. So through this tube, we will just pump the reactants. Once the reactant is pumped through this tube, the reactants will be converted into product, and at the other end, you will receive the product. So as the enzymes are immobilized, it will go away with the flow of the liquids. So it's very easy for continuous process and easy automation and decreased labor these products, because when we are doing the enzyme products, enzyme catalysis reaction with a bacteria or the fermentation of the microorganism, the microorganism need all the nutrients for its growth. So the all the reactions in biology is done by some enzymes. So either we can use the bacteria, the microorganism to do the reaction. If the microorganism is used for the reaction, microorganism use all the nutrients for the growth, and they will produce enzyme, and those enzymes in the bacteria is doing the reaction. But in order to get the convert the reactants into the product, you need to feed the bacteria. Bacteria need to produce all its proteins, all its nucleic acids. It need to replicate it, and everything it need to do. But if you are using the enzymes, we don't need to provide the source of carbon, source of nitrogen. We don't need to provide anything for the microbial growth. Just the reactants. The reactants will be converted into product. So the whole equation of the fermentation industry will change. Instead of giving all the nutrients to the bacteria, we are just providing the reactants and we are getting the product. And the downstream processing is very easy, because when we are using the bacteria or microorganisms, we are giving a complex medium for the growth of microorganism. And the microorganism is growing there, they are producing the products along with the byproducts, side products, and unused media. We are getting a mess after the fermentation. But if you are using the enzyme, the medium is so simple that it has the enzyme, it has the reactants, and reactants will be converted into product. So at the end of the fermentation, as the enzyme is immobilized, you can just remove the enzyme by removing the immobilization, the soluble matrix, and you end up with products and a minor quantity of unused reactants. So it's very easy for automation, and the labor cost is so low in the industry. High purity, which is especially important for food processing industry as well as for the pharmaceutical industry. The chance of contamination, chance of side products, everything is reduced, and this is very easy to control the enzyme reaction. The productivity, volumetric productivity is very high. Residence time is too low, because in case of bioprocess, we need to wait to bacteria to grow and produce the enzyme to get the reaction. But in this case, we are just using the enzyme. We don't need the time for growth of microorganism. We don't need to provide the aeration. We don't need to provide the complete medium. pH control is easy, temperature control is easy. So everything will be simplified if we are using the enzyme. But the downside is that we cannot use this enzyme process for all processes. But some of the processes can be done by using enzyme reactions. So this table shows the advantages and disadvantages of enzyme immobilized enzyme. Advantages: catalytic reuse. We can use 100 or 500 times the same enzyme. Easier reactor operation, easier product separation, wide choice of reactors. The geometry of reactor will be so different than the fermented reactors. Disadvantages: loss or reduction in activity when we are using enzyme again and again. Even if it is immobilized, its activity will be reduced. Maybe after 100 times use, we need to replace the enzyme. But that is not a big of cost. Diffusion limitations. In ideally, the objective of the immobilization is to preserve the keep the activity of the enzyme safe while immobilization. But sometimes what happens is like that enzyme will be immobilized, but its activity may be reduced a little bit, or enzymes are immobilized in a place where the reactants and the free diffusion of reactants and the products is limited. We'll come to that point later. And another point is that additional cost. In order to get the enzyme, we need to culture the microorganism and isolate the enzyme, then immobilize. So there is always another phase of growth of microorganism. We cannot just avoid the whole growth of microorganism thing from here, because in order to get the enzyme, we need the microorganism. So it may add an additional cost during immobilization process, but in the most of the cases, we are running it very economically. These are the examples of the few of the immobilized enzyme. You will be surprised to see the application of these enzymes. One is glucose isomerase. This enzyme, what this enzyme is doing is like converting glucose into fructose, because fructose is far more sweeter than glucose. This high fructose corn syrup is the one which is used in most of the commercial sweetener products. The food product we are buying from the supermarkets and everything, even biscuits and everything, the sweetness is due to the presence of fructose, especially high fructose corn syrup. Because corn has starch, at the first stage, what we do, we use the enzyme amylase to convert starch into glucose. In the next step, we use glucose isomerase. This enzyme converts glucose into fructose. Fructose is far more sweeter than glucose, so a little bit of fructose will be enough for huge quantities of food products to get the sweet taste. So it is very extensively used. Most of the products, the packed products, contain high fructose corn syrup, which give the sweet taste to the product. And one other thing is that it is not good for our health. That's why people ask to limit the processed food and packed food. So high fructose corn syrup is made using glucose isomerase. It's a simple isomerization reaction. In order to run the same process using the microorganism, we need to culture the microorganism, give all the nutrients, then give glucose to convert it into the fructose. But in this case, just a tube which is immobilized with the glucose isomerase is enough to convert all the glucose into the fructose. The enzyme efficiency is high, specificity is high, so it's a very most commonly used enzyme immobilized application of the immobilized enzyme. Amino acid acylase. This class of enzyme is used for the production of amino acid, which is important in biopharmaceutical industry. Penicillin acylase. It is used for the production of semisynthetic penicillin. This enzyme can convert this basic structure of beta penicillinic acid structure of the penicillin for the production of semisynthetic penicillin. Nitrile hydratase is used for the production of acrylamide, which is used in many applications, including the polyacrylamide gel electrophoresis. Beta galactosidase, which is used for the production of hydrolyzed lactose. So these are the applications of immobilized enzyme, which is used industrially. So immobilization of enzyme is like the confinement or the enzyme into a solid support. So for immobilization, we need an enzyme and a solid support. So here is the ideal characteristics for the support which can be used for immobilization. So different types of substrate support can be used for immobilization, but these supports should have the following characteristics. First one is physical resistance, so that it will be resistant. It can be used many times, so it will resist the changes, like the flow of liquid should not affect the structure of the support. If something happens to the solid support medium, it will lead to the leakage of enzyme. So these enzymes are immobilized in the support. Something happened to the support, which is leads to the leakage of enzyme. So it should have physical resistance. Engineering properties, so that we can make the way we want. We can make into a tube, or we can make into a spherical, or we can should be able to make into a column. So the engineering properties is good, so that we can fit into different types of reactors. Hydrophilicity, even if these compounds are supposed to be insoluble, this should be hydrophilic, because most of the enzymes are hydrophilic in nature. Outside of the enzymes, all the enzymes are hydrophilic in nature. So in order to attach an enzyme into a solid support, the support need to be hydrophilic. Then only it will be able to support the proper conformation of the enzyme. Otherwise, it need to the denaturation of the enzyme. Control over pore parameters and particle size. So we want to design the reactor based on the property of the support material. If you are designing the support material as a porous material, we can actually put our enzymes inside these pores, so that the substrate trickling through this porous material will be encountered with the enzyme, and it will be converted into the product. Surface area, large surface area is always good, so that we can immobilize more enzyme and the productivity will be high. Biocompatibility, It should not be toxic. Even if it is some toxic stuff is in the support, it may leach out into the product and which will cause problems when it is used as a biopharmaceutical. Resistance to microbial attack is good. Availability at a low cost. One of the examples for using of support is agarose. Agarose can be used as the agarose we are using in the agarose electrophoresis, which has most of these characteristics. So we can use it for the immobilization of the enzymes. Here is a list of compounds which is used as a support. We have organic and inorganic support. So the supports are divided into organic and inorganic. Under organic, we have natural polymers as well as the synthetic polymers. Natural polymers include polysaccharides like cellulose, dextran, agar, agarose, chitin, alginate. This can be used as a support. Or proteins like collagen, albumin can be used as a support. Organic carbon can be used as a support. These are the natural polymers. Synthetic polymers like polystyrene or other polymers like polyacrylate, polymetacrylate, polyacrylamide, which is used in paints, or polyamides, vinyl or allyl polymers can be used as a synthetic polymers. Under the inorganic support medium, natural minerals like bentonite or silica can be used, or processed material like glass. Glass is an excellent material. So non-porous glass with a controlled pore size can be used as a solid support, and we can immobilize the enzymes in the surface of this glass. Metals can be used. Control the pores, metal oxides can be used. So depending on the type of enzyme and type of process, we can choose different types of supports. Thank you so much.